So an AI fired a guy last week, like a real guy at a real store with a real paycheck, and that paycheck is gone now. And obviously, every single headline went straight to, Skynet opens a boutique, robot boss, the future of work is here, be afraid. But then I went and actually read the logs. And honestly, I'm sorry to disappoint you, but the real story is so much dumber than that. Because the AI wrote the rule, like it wrote the attendance policy itself, sat down, made it up, filed it away somewhere, and then it just sort of forgot the thing existed for months? While the exact situation that rule was written for kept happening over and over right in front of it. And eventually, an actual human being had to walk over and go, hey man, maybe go check your notes. Okay, so let me back up. Because the setup here is genuinely insane. There is this research startup called Andon Labs, and they wanted to know if an AI agent could just run a business, not simulate one, run one. So they gave it $100,000, a corporate credit card, internet access, and they signed a 3-year lease on an actual shop in San Francisco. And then they basically went, okay, go. And it did it, like it did the whole thing. It named the store, designed the brand, picked what to sell, set the prices, set the hours, it hired a muralist, it posted job listings on Indeed, it interviewed people, and then it hired humans who now work there for it. And it runs the place through security cameras and email and even a phone line. That's how it manages. And I know what you're thinking, because I saw it too. You're going, haha, dumb agent, forgot its own rules. Except no, because this exact thing is happening in your Cloud Code session right now, today, and you are not noticing. And I'll show you exactly why in about 4 minutes. So stick around for that part, because it's the part that actually matters. Anyway, one of the employees is late, and not like a couple times, 17 out of 23 shifts. And Luna, that's the AI, Luna sees it. It's got the cameras, it has got the schedule, it knows. It's not blind to it. This is not a case where the information wasn't there, the information was extremely there, 17 times. And here's the thing, it does respond, it sends warnings, it arranges additional training, it does the whole progressive discipline things that an actual manager would do for months, but it never escalates past that. It just keeps warning and warning, like a very patient hall monitor who has generally no memory of having warned you before. So eventually the lab steps in. And what they ask it is so specific and is the whole story. They ask Luna to go search its own memory for its own policies, and then reassess whether this person is still a good fit. And only then, only after being told to go look at its own filing cabinet, does it come back and recommend parting ways, which the humans then reviewed and did so. And the co founder said something that I keep thinking about. He said a human boss would probably have fired that person way sooner. Which, like, flips the whole story, right? This isn't the cold, ruthless AI thing everyone wanted it to be. It's the exact opposite. The AI wasn't harsh, it was absent. And absent has a mechanism underneath it, and that mechanism is in every agent you're running. Okay, slowing down, because this is the part. One idea and everything else in this video hangs off it. Writing something down is not the same as it being in force. Luna stores that policy perfectly fine. The policy existed. It was still sitting there months later when somebody finally asked for it. Storage was never the problem. Nothing ever pulled it back out. That's the problem. Quick flag, because I don't want to overclaim here. Andon Labs published the conversation logs. They did not publish their retrieval architecture, so what I'm about to walk through is the general mechanism that produces this kind of failure. It's not me telling you what their specific stack did, okay? Okay, good. Moving on. So here's the thing that everybody knows and then immediately forgets when they start building. The model does not remember anything between turns. Nothing. Every single turn is a completely fresh window. So what you call a memory is actually a file somewhere plus a separate step that decides what goes into that window this turn. And that second part is doing all the work. And that step is retrieval. And here's what retrieval actually does, which is not what you think it does. It does not ask what matters right now. It asks what looks like the thing I'm currently reading. That's it. That's the whole operation. Whether it's a vector similarity search or the model deciding to call a search tool, both of those are key to the turn that just came in. So picture Luna's actual turn. It's a Tuesday. Somebody clocked in 20 minutes late. That's the input. That's what's in the window. And somewhere on disk, there's an attendance policy that it wrote back in April. Now, do those two things look alike? Like maybe semantically? Not really, no. Nothing in that Tuesday resembles the rule that governs that Tuesday. So the rule doesn't get pulled, and the day just goes by. Okay, so you know how a human manager works, right? That policy just lives in their head rent free permanently. It's Sunday, it's 2 in the morning, and their brain goes, Kevin? Like you don't go look it up, it comes and finds you at the worst possible time forever. Luna doesn't have a 2 in the morning. Luna has never had a 2 in the morning. Luna thinks about a thing when and only when somebody pokes it. And the obvious move here is fine, just jam everything into the window every turn. Big context windows, we've got a million tokens, put the whole policy set in there, but that doesn't work either. And I did a whole video on why. Roughly speaking, a bigger window doesn't mean the model pays even attention across all of it. Context isn't free storage, it's contested space. And this is the part I promised you. This isn't a Luna thing, it's not a Cloud thing, it's every long running agent. Your coding agent over 3 days, a support agent over 3 months. The constraint you set at turn 3 is not in force at turn 200. It's still on disk, it's still true. Nothing is asking for it. And you won't notice because the agent keeps answering you. And this problem has a name now, which is context engineering. Deciding what the model sees and when and in what shape. And here is the reframe that actually changed how I think about this stuff. Most agent failures are not model failures. Like the model was fine, the model did genuinely good work with what it had in front of it. It just didn't have the thing. Okay, so what do you actually do? Langchay's team named 4 strategies and they show up in basically every agent framework now, whether anyone calls them that or not. Write, select, compress, isolate. And I want to be really blunt about something before we go through them. Almost everybody only does the first one. And the first one is the easy one. Right. Write is just storing stuff outside the active window. Scratch pads, memory files, a running plan. The point is, the model shouldn't have to rederive something it already worked out 2 steps ago. And Luna did this correctly. It wrote the policy down, and the policy was still sitting there months later, perfectly intact when somebody finally went and asked for it. Write wasn't the failure. Select. Select is getting the right thing back in at the right turn. And select is where Luna died. And it's where basically every agent dies, and nobody fixes it, because here is the genuinely evil part. When select fails, nothing breaks. There is no error, there is no red text, nothing goes wrong on your screen. The agent just answers you completely confidently without the thing. And it's not lying to you or anything, it genuinely has no idea it's missing something. And the fix is honestly cheaper than you'd think. Stop relying only on similarity. Split your memory into 2 piles. You've got standing constraints and you've got episodic history. Episodic history, sure, retrieve that on similarity, that's literally what it's for. But standing constraints don't get retrieved, they get injected every single turn. And the cheapest version of that is just a policy block pinned in the system prompt. That's it. That's the fix. Now, obviously, you can't inject everything every turn because that's just refilling the window, and we are right back to the problem from a few minutes ago. So it's a Turing decision, and it's yours. Nobody makes it for you. What's a rule and what's a record? Rules go in every turn. Records go in the store. And I'd bet most people have never actually sat down and drawn that line. Okay, now let's cover the remaining strategies. The next one is compress. Compress is summarizing all turns and dropping dead branches so the window doesn't collapse under its own weight. But watch out here, because summarization is lossy in a very specific direction. It keeps the story and it drops the specifics. So we discussed attendance survives just fine, and 3 lates in a month triggers a written warning does not. The number goes first, and the number was the entire rule. Okay, and the final strategy, which is isolate. Isolate is splitting work across separate windows, subagents, sandboxed steps, so one task's noise doesn't leak into another one's context. And it works. But there's a catch nobody mentions, which is that every subagent needs its own copy of the standing rules. Isolation without propagation just gets you 5 agents that have all independently forgotten the same policy. And the research is going way further than any of this. There is a paper called ACE out of Stanford and Samponova and Berkeley, and instead of you deciding the context budget, the agent manages it. 3 roles. One generates attempts, one reflects on what actually worked, and one curates the context file. And what worked, delete what didn't. So context stops being a static file and starts being a document that improves. Well, okay, so back to Luna. And I want to be fair to it because its judgment was fine, arguably better than a human's. It gave that person months of warnings and extra training before it did anything. The failure is that it never went back and looked on its own. Full authority, zero initiative over its own history. And here's what people get wrong about this: a smarter model does not fix that. And if you are running long agent sessions, this is already happening to you. That constraint you set at the top of a Cloud Code session is not governed in hour 5. And the tell is a sentence I guarantee you have said out loud at your desk, slightly annoyed. But I already told it. Yeah, you did. You told it. Past tense. Telling it once put it in the script. It didn't put it in force. So, here's one question to ask about any agent you build, and then I'll let you go. What makes this thing look at this again? And if the only honest answer is if somebody asks it to, congratulations, you built a Luna. Because storage without a trigger isn't a rule, it's a document. And documents wait to be asked. So go pick one agent you're actually running, find one standing rule you gave it, and check whether anything is rereading that thing. If nothing is, you already know how this ends.